Hello and welcome to Starfish Maths. My name's Sarah and today I'm going to look at vectors. In this video I'm going to show you what a vector is and how to find its magnitude and direction. We'll look at coordinates and vectors between them, position vectors, and we'll finish up with some 3D vectors. So do grab a pen and paper, pause the video and rewind as you need to do some of the work yourself. Let me know if this is helpful. Do leave a comment below or drop me an email, starfishmaths@gmail.com, or you can get in touch on the website starfishmaths.com. Great, if you're ready, let's get started. So a vector is a quantity that has both a size and a direction. So we can represent a vector with an arrow, with the arrow pointing in the direction that it's going. So let's take this vector to start with and say this is going 3 units along and 2 units up, for example. Then we can write that vector. We'll call it V. Now, a vector is different from just an algebraic letter. A letter in algebra is a scalar, it's like just a number. But vectors are different and we need to show that in the way that we're writing them. So when they're printed or on screen, they tend to be in bold, lowercase letters. But when we're writing them, it's difficult to write in bold, so we tend to underline them. So you must be careful to underline your vectors if they're in lowercase. So that's our vector V, and I said it's 3 along and 2 up. So we can write that in component form in 2 different ways. First of all, we can write a column vector. So that's showing on the top you put the number in the horizontal direction, and on the bottom you put the number in the vertical direction. So to the right is positive and upwards is positive. So we're doing 3 along in the positive direction and 2 up in the positive direction. Now if your components were going left and down, they would be negative. So that's a column vector, and we can also write it using unit vectors. Unit vectors, we tend to use the letters I and J. So I and J are just these little pieces that I've sort of put with dashes here. So like when I said 3 along, I mean like 3 units along. And we tend to call those little units in the horizontal direction I, and the units in the vertical direction we call J. So we can write this as 3I and 2J. And again, if it was left and down, those would just be negative. So that's how to write a vector, and then you can also find its length and its direction if you want to. If you want to find the length of this vector, that's called its magnitude, and we can write that using vertical lines around the vector. That just means the magnitude of the vector. Now when you look at this right angled triangle that I've sort of drawn here, we've got 3 along in the horizontal and 2 up. And when you've got a right angled triangle, you can just use Pythagoras. So the length of that vector there will be found using Pythagoras. So that would be the square root of 3 squared plus 2 squared. And another thing you can do if you want to, or if you're asked, is to find the angle that the vector is acting in. So say we want to find this angle that it makes with the horizontal here, we'll call that theta. Then again, we're in a right angle triangle, so we can use basic trigonometry here, and we know these components 2 and 3. So we tend to use tan. Tan is opposite over adjacent. So that angle there will be found using the inverse tan of the opposite over adjacent. And on my calculator that gives me 33.7 degrees. Another way that you can write the direction is using a bearing. You may know that bearings are always measured from the north line round in a clockwise direction. So the bearing of this vector would be this angle here, I'll call it alpha, and that would be 90 degrees take away that theta. So to the nearest degree, 90 take away 34 gives me 56, and a bearing is always written in 3 figures, so 0, 5, 6. Great, let's just practice all of that with another vector now. Okay, I've kept V here because we're going to use it again. It's the same one that we just did, but I put a new vector here, U, and have a go at either sketching this vector out, and can you also try and find the magnitude and the direction of it. So do pause the video and have a go at that. If we want to sketch this out, it's going -1 in the horizontal, so that's left 1, and still +5 in the vertical, so up 5. Left 1 and up 5. It'll look something like that. And to find the magnitude of it, we're using Pythagoras again. When I write Pythagoras, I've just ditched the negative sign there because we're squaring it, so -1 squared is the same as +1 squared, so that's fine. And that gives me root 26. The direction of the vector, let's find the angle it makes with the horizontal again. So I've labelled that as theta, and I'll use inverse tan. So I've put inverse tan of 5/1, so that's using this right angle triangle if it's 5 in that direction and 1 in that direction. We don't need to worry about negative signs here because we're just looking for this angle in this triangle. Obviously this isn't drawn to scale because that doesn't look right, I know, but it gives you an idea anyway. So that angle there, I get 78.7 degrees. And again, if you wanted that as a bearing, have a go at finding that as a bearing. A bearing is measured from the north line clockwise, so it would be all the way around there. So it would be that little angle theta plus 270. And I make that to the nearest degree as 349 degrees. Well done if you got that. Okay, I've left them on there because now I want to show you how you can put vectors together. So let's have a look at what happens when we add these two together. So we can add u and v. So adding those components together, 3 plus -1 just gives us 2. And 2 plus 5 gives us 7, or you can add using the i's and j's. It's good to be able to use either way of writing, so be familiar with your i's and j's and your column vectors. I tend to personally use the column vectors more, but I'll try and alternate a little bit in the video. So that's the u plus v just added together very simply. And just showing you what that looks like represented with the arrows again. So just drawing a sketch of u plus v, we'll start with u. U is 1 to the left and 5 up, so that was something like that. Just a sketch, not brilliantly drawn, but you get the idea. And when we add vectors together, u plus v, the next one will go on along from the end of there. So v is 3 to the right and 2 up, so something like. So representing u plus v, if you have u and then v following on from each other, then the resultant vector, we call it, is the alternate route from the start to the finish, so that direct route there. And it's worth just showing that in a different way. I tend to put a double arrow on in the middle because that's the resultant vector. So that's the same as u plus v. So when you do a sketch, it's good to have this route following on from each other, and then your resultant vector is the alternate from start to finish. So notice which ways the arrows are going there. So our u plus v, it should be something like 2 along to the right and 7 up, which kind of looks like, but that's what's going on there. So just to practice that so far, have a go now at looking at 2u minus v, find that vector and get the magnitude of it. Have a go, pause the video and have a go. And you might also like to draw a sketch and see what that looks like as well. So I'll use the i's and j's this time. 2 lots of this minus this, so -2 minus 3 is -5. And 2 lots of that minus that, 10 minus 2 is 8. And we're finding the modulus of that, and I make that to be root 89. Great, so we've covered so far how to write vectors and how to find the magnitude, how to draw them, and how to find the directions. So now I'm going to show you coordinates and how to get some vectors between coordinates. Okay, so here we've got some coordinates. Now you'll hear the words position vectors, and a position vector is simply how to get to those points from the origin. So if you're going from 0, 0 to these points, you just need the vectors with the same numbers. But a position vector is a way of writing those numbers as a vector. So it's kind of turning a coordinate into a vector kind of thing. So it's literally just turning it round into a column vector or into i's and j's. So coordinate is typically written with an uppercase letter, and the position vector lowercase and underlined because it's a vector. So just being a bit careful about all those things. So it's those same numbers, 3 minus 4, but now turned into a vector. And that can also be written, I said it's from the origin to that point. So another way of writing a vector is from one point to another point. So here, origin to A, with a little line over the top. And we'll do the same for B, so turning that into a position vector is just turning it around into a column vector. And you can also write that as the origin to the point B with an arrow over the top. Good, so the next thing I want to show you is how to find a vector from one point to another point. So the vector from A to B. Now you can sketch this out, so you can plot those points and figure out how many, one way and the other way as a vector. However you want to try it, have a go, pause the video, to get from A to B. So I'm going to write this as a vector like I did with these ones, so one point to the other point with an arrow over the top, A to B. So let's look at the x-coordinates. To get from 3 to minus 2, I need to take off 5. And to get from minus 4 to minus 1, I need to add 3. That's the way I think of it. Another way you can think of it is this number take away this number. So some people, if you like a formula, would do it as the B position vector take away the A position vector. So this one take away this one. Good, and just to carry on practicing the magnitude, because that's a very important thing, find the magnitude of that vector A to B. Do have a go using Pythagoras, so 25 plus 9, and I make that to be root 34. Okay, I'll just put another kind of question on here that we can have a think about, and that is find the point C so that A to B is the same vector as B to C. Just as a little sketch, if A and B are here and your A to B vector is this one, it's a bit wobbly, but you know what I mean, then we want to find a point C like that so that it's the same vector again. So we want this same vector to be the same as AB, so minusing 5 in the horizontal direction and 3 up in the vertical direction on from B. So you could do this algebraically if you wanted to, or you could just think through. We're at B and we want to take off another 5 from the x, so minus 2 take away another 5 would be minus 7, and adding 3 to the y coordinate would give us 2. But do have a play around with that. There are different ways of doing it. See if you can find another way of getting that point. And before we move on, just one more thing to mention, and that is parallel vectors. Any vectors are parallel to each other if they're just exact multiples of each other. So any vectors that are parallel to this one will just be if you're timesing both these numbers by the same amount. So if we double them and get minus 10 and 6, that's going to be parallel to that. Or if we triple them, so we get minus 15 and 9, then these are all parallel, and so on. So as long as they're in the same proportion, so you're multiplying it by the same thing, then they're parallel. So that one there, A to B, would be a little arrow. This one's double the length, but it's still parallel, and this one's triple the length, but it's still parallel. So just developing here a little bit more, I've kept A and B, and we've still got our vector AB is minus 5, 3, and now I put a new vector with a new letter, a new point, AD, minus 1i plus 3j, just to practice our i's and j's, And this time, find the angle between those two vectors, AB and AD. So do pause, have a play around, see if you can figure it out. I think it would be really useful here to draw a sketch. So let's draw AB and AD. Okay, so a wiggly sketch, A to B here, minus 5, 3. And then we've got A to D. And then we want to find the angle that's in between these. So let's perhaps close up this triangle. We don't have a right angle triangle, we've just got an irregular triangle. But we can absolutely use the sine and cosine rules on this triangle. And we can use the magnitudes of the lengths to do the cosine rule. So we can put the lengths of the sides on here. So A to B, I think I rubbed it out actually, but I think we already found the magnitude of AB was root 34. So we need the magnitudes of these ones. So do have a go yourself and find the magnitude of A to D. I get root 10. And now we need to practice finding a vector from these 2 points. Let's do B to D, let's go that way. B to D. Now to do that, to find the vector B to D, we can use what I showed you at the beginning. So like using a resultant vector. So B to D, from the start to the finish point, the alternate route would be to go down here and then up here. So that way and then up that way. So that's the same as that vector. This one's going the opposite way though. So this one's B to A instead of A to B, which is the same, but it will just reverse the signs. It'll make it negative. It's going to be like negative AB and then plus your A to D. Hope that makes sense. You might have done that at GCSE actually. So let's see what that looks like with the numbers. So that, instead of minus 5, that will be positive 5 and then plus a negative 1. So that's 4. And then instead of positive 3, we'll have negative 3 and plus a positive 3. Which is 0. So that's just 4i. So the magnitude of that is really easy. It's just 4. Great, now we can use the cos rule on this triangle to find that angle. So if you need to brush up on your cos rule, I have another video on it, but I'm going to use the rearranged version. I'm doing this quite quickly actually. I'm not guiding you through the cos rule here because I'm assuming you can do it. But if you do need to practice that, do check out my other video. So theta is the inverse cos of that, and I make that to be 40.6 degrees. Great, well done if you got that. We're going to finish today with looking at vectors in 3 dimensions. It's all the same stuff, it's just an extra letter or an extra number, so don't panic. Okay, finishing with a question using vectors in 3 dimensions. As I said, it's the same stuff. It's just an extra number. So we've got 3 dimensions, I, j and k if you want to use the unit vectors, I, j and k. And it's just literally an extra one. It's all the same stuff. So this time we've got a question that the coordinate b divides the line AC in the ratio 1 to 2. Find the magnitude of the vector B to C. So we'll start with a sketch. It's hard to sketch in 3 dimensions. You just put it anywhere really, it doesn't matter at all, don't worry about it. Let's put A here and let's put C here. B divides AC in the ratio 1 to 2, so maybe something like that. So that fits twice into that bit there. So it would be a good idea to start off with finding the vector A to B. And it's the same way as we did it in the last example. So using either the position vector B take away A, or just by looking at what we need to get from here to here. Whichever way you do it, I make it to be that vector. Now BC is twice AB. It's the same, but just double it. So we can just double those numbers. 4 minus 6 and 2. It's that simple. And then finishing with finding the magnitude of that. And again, don't panic, we're in 3 dimensions, but use Pythagoras in exactly the same way. So Pythagoras does extend to 3 dimensions. We can just do 4 squared and minus 6, or 6 squared and 2 squared, all square rooted, it's the same. And that gets us root 56. So there you have it. That's just one example of 3D vectors. Hopefully you can see it's not much more complicated than 2 dimensions. It might be that vectors feel weird to you because they're so different from your normal maths with just numbers. If that's the case, just practice as many questions as you can find. It's just a case of practicing so it feels familiar to you. But I hope this video gave you a taste and a flavour for the different techniques you need, and I hope it was helpful. Well done, and thank you for watching.